March 23, paper 2, variant 2. Which list contains two scalar quantities and two vector quantities? Okay, distance, speed, time. Okay, so I have three scalar quantities. B. Force and velocity, two vectors, distance and mass, two scalars. Yes, this is correct. The diagram shows the speed time graph for a car, which row describes the motion of the car at point X and at point Y. At point X, what's happening to the motion of the car? What's happening to the motion? It's increasing. The speed is increasing. It's at rest, no. Moving with constant speed, no. Moving with a changing speed, yes. At Y, it's moving with a constant speed. This is a speed time graph. Four objects are moving in a straight line. The table shows the distances moved by each object in each second of its motion. Which object is moving with constant non-zero acceleration? Non-zero acceleration means that it's increasing, right? The speed, okay, is increasing. This is moved by the car 5, 5, 5, 5. The car is at rest, right? Or the car is actually moving with a constant speed. This is moved in the first second 5 meters, second 5 meters, third second 5 meters. So the distance moved per second or the speed per, it's constant. So this is wrong. What about B? 5, 6, 7, 8. So what's happening to the speed? It keeps on increasing. This is a constant non-zero acceleration. It's a constant acceleration. How did I know that it's a constant acceleration? Because the velocity kept on increasing with the same rate each second. Kept on increasing by one, by one, by one. This is constant acceleration. Someone might say, what about C? No, C is wrong. Why? Because it increased by 2 and then by 3 and then by 4. So this is wrong. This is an increasing acceleration. Okay, C and D are wrong. So it is B. Drag force on a car increases with the speed. At 20 meters per second, the total drag force is 400 newtons. The mass of the car is 1,200 kilograms, and the driving force is constant at 700 newtons. Which statement about the acceleration of the car at 20 meters per second is correct? Can I find the acceleration of the car? Yes, I can, because force equals mass times acceleration. But force, this is the resultant force, right? This is the resultant force, which is the driving force minus the resisting force. So 700 minus 400, this is 300 newtons. This is the force acting on the car. Can I find the acceleration? The acceleration would be equal to force over mass. So 300 over the mass, which is 1,200, giving you an acceleration of 0.25, right? This is an acceleration of 0.25. Will it decrease or will it increase as time passes? It should decrease as time passes. Why should it decrease? Because as the speed increases, the resistive forces increase and thus the acceleration decreases. Let's say a rectangular swimming pool is 50 meters long and 25 meters wide, contains water at a depth of 2 meters. The density is 1000. What is the mass? Mass equals density times volume. 1000 times 2 times 15 times 25. This is the volume. Yeah, it's a huge mass, 2,500,000 kilograms. An object is rising vertically at a constant speed. Rising vertically at a constant speed. There are three vertical forces acting on this object. The weight W, the drag force D, and the upward force U. So it's rising upwards at a constant speed, which diagram shows the magnitude. So for it to rise upwards at a constant speed, U needs to be upwards. Okay, so all of them has U upwards, and then W has to be downwards. All of them have W downwards. What about the drag force? Drag force has to be in the opposite direction as U. So A is wrong, B is wrong. So it's either C or D. Should it be C or should it be D? If it's moving at a constant speed, then the upward forces should be equal to the downward forces. 3 is equal to 1 plus 2, so it is D. Two boys of equal weight sit on one side of the seesaw. Their father of weight 1000 newtons sits on the other side of the seesaw, and now it's balanced. Okay. During one part of the cycle, the father descends through a distance of 40 centimeters. At the same time, the boy nearest to the pivot rises through 20 centimeters, while or the other boy rises a distance of 80 centimeters. What is the weight of each? This question is very, I don't want to say difficult. No, it's not difficult. It's just very tricky. Okay, it's very tricky. If the father has a weight of 1000 newtons, say he has a weight of 1000 newtons, and he descends a distance of 40 centimeters. 40 centimeters. The other boy, the closer boy, rises a distance of, let's say, 20 centimeters, and the other boy rises a distance of 80 centimeters. Can I try and solve it this way? For example, you have force and distance and force and distance. You have a moment question. Can I try and solve it in this way? Yes, I can. The father is exerting an anti-clockwise moment, and they are both exerting two clockwise moments, right? Two clockwise moments. So if I write down clockwise moment is equal to the anti-clockwise moment, the boys both have a weight of W. So if I say W times 20 plus W times 80, this should be equal to 1000 times 40, right? 1000 times 40. So this is 40,000, and you have 20W and 80W, which is 100W. Can I find the weight? Divide by 100. 40,000 divided by 100, this would give you a weight of 400 newtons. You can solve it as easy as that. This is the solution. A student measures the length of a spring. She then attaches different weights. The table shows her results. What is the extension when the weight of 3 newtons is attached? 3 newtons. When you attach a weight of 3 newtons, can I find the extension? Yes, 520 minus, or 533 minus 520, which is 13 millimeters. Momentum of body is changed by a force acting on it for a period of time. Which action increases the change in momentum? How can I increase the change in momentum? Doubling the force and halving the time. This is wrong because it would be the same. Doubling the force for the same time. Okay, seems about right. No, this is wrong. Halving and doubling. No, this is wrong again. So the only question or the only answer would be B. Equation is used to find the gravitational potential energy. Okay, where delta E is the change in gravitational potential energy and delta H is the height. We know that gravitational potential energy is mgh. So h is the height, so y has to be mass, for example, and z has to be the gravitational field strength, or the other way around, but you don't have the other way around. So it's only A. A machine has a power input of 200 watts and a useful power output of 1 kilojoules in 6 minutes. What is the efficiency of the machine? The output is 1000 joules in 6 minutes. The power energy over time, 1000 divided by 6 minutes, so 6 times 60. What's 1000 divided by 360? 2.7. This machine is very inefficient, right? So 2.7 divided by 200. Okay, and if you want to multiply by 100 to find the percentage, this would be 1.38 or 1.39 or 1.4%. What is the unit of power? What What is the pressure at the base of the block due to its weight? So it has a weight of 16 newtons. Pressure equals force over area. 16 divided by the area of the base. What was the area of the base? It's 4 times 5. 4 times 5. 0.8 newtons per centimeters squared. Again, if you wanted to find this area, if you wanted to find this pressure in pascals, you need to convert the unit, the distance, into meters. You have to convert the distance into meters. An oil tank has a base of area 2.5 meters squared and is filled with oil to a depth of 1.2 meters. Density is 800. What is the force? Okay, so we can say force over area equals rho gh. To find the force, it would be rho gh times the area, or 800 times 9.8 times the height, which is 1.2, times the area, which is 2.5, giving you a force of around 24,000 newtons. A sample of gas is trapped in a rigid container. As the temperature increases, the pressure increases. Which statement is not correct? Which statement is wrong? The molecules have greater kinetic energy. They do, because the temperature increases. The gas molecules hit the walls harder. Yes, they do. Molecules hit the walls more frequently. Yes, definitely. They move further apart. No, they do not. Why? Because this is a rigid container, because the volume is constant. What happens when the temperature of a liquid increases? When the temperature increases, what happens? Does the mass increase? No, it does not. The volume increases, yes, making the liquid less dense. Convection. A bar of metal, which is a good thermal conductor, is heated at one end. What is the main method of transfer of thermal energy along the bar? That is vibration, movement of atoms, transfer of electrons, vibration of atoms of the metal bar. Which of them would be correct? Transfer of electrons is the fastest way in which you... Lattice vibration is correct. Lattice vibration is not wrong, okay? But the transfer of the electrons is the fastest way by which you can transfer the energy. 18. A transverse wave moves along a rope. The diagram shows the position which two labeled points are one wavelength apart. So you have from X all the way to Z. This is one wavelength apart. Light in transparent plastic meets boundary with air. Light is transmitted into the air only if the angle is greater than 36. Only if the angle is what is greater than 36. So if it's less than 36, it would not transfer out into the air. What is the refractive index of the plastic? If this is 36, is this the angle of incidence? No, it's not the angle of incidence. This is the angle of, or it's not an angle. We need to find the angle of incidence by subtracting 90. Okay, 90 minus 36. What's 90 minus 36? This is 54, right? 90 minus 36 is 54. So technically, you'd say that the critical angle is what is 54. That the critical angle is 54. Can I find the refractive index if I have the critical angle? Yes, n equals 1 over sine 54, right? 1 over sine c, which is 1.2. 1 over sine 54. A thin converging lens has a focal length of f. An object O is placed to the left of the lens, as seen. Where is the image formed and how does the size compare to the object? So if the object is at a distance less than the focal length, then the image would appear on the same side. Why? Because it's a virtual image. It would appear on the same side, upright, enlarged, right behind the object, and it has to be larger because this is a magnifying glass. Which diagram shows what happens when a ray of light passes through a prism? Gets dispersed. So A is wrong. B, no, it's dispersed downwards a little. C, and then when it exits the prism, it will move downwards as well. So it has to be D. A television satellite transmits signal to a receiving dish. Which electromagnetic wave is used in these actions has the longest wavelength? Which of these has the longest wavelength? So from the TV station, this is microwaves. We have the microwaves. Okay, this is the infrared, right? Infrared, and then C and D are the visible light. You can write in the Rami looks great. So radio waves is the longest, and then microwaves. So microwaves are longer than infrared and visible light. The student makes a list of some applications of waves. Which applications are used? Which applications use ultrasound waves? Which of these applications use ultrasound waves? Let's see. Medical scanning of soft tissue. Yes, medical scanning of soft tissue. Sterilizing water. No, not ultrasound, ultraviolet. Right? Using sonar to calculate the depth. Yes, 1 and 3. Echo. Right? An echo. Diagram shows a bar magnet near a soft iron wire. What happens when the wire is released? Isn't this iron? Yes. And it's near a magnetic field. So if I have iron near a magnetic field, what would happen to this iron? It would be attracted, right? It would be attracted to the magnetic field, so it would move towards the magnet. It will move towards the magnet. Which diagram shows an electric field pattern around the positive point? Positive point, so it's outwards, right? Positive point is outwards. A laboratory has a standard wire of known resistance. It has other wires. Which wire would definitely have a resistance less than the standard? Less than. How can you decrease the resistance? By decreasing the length. So you need a shorter wire and a larger diameter, right? Shorter wire and a larger diameter. You have a current and potential difference graph. What happens to the resistance in these two sections? In the straight section, if you have a straight section, then this is a constant resistance, right? At any point, if you calculate the resistance, it would be constant. But in the curved section, when it is curving towards the voltage axis, when it is curving towards the potential difference axis, what happens to the resistance? The resistance actually increases, right? The resistance increases. So no change in resistance, and then the resistance increases. What is the combined resistance of these resistors? So I have 2 and 1, they are in series. They are actually 3 ohms. Can I calculate 3 and 4 if they are in parallel? Yes, product over sum. Product over sum. So 3 times 4 over 3 plus 4, right? Which is 1.7 ohms. Product over sum. Voltmeter reads 6 volts. What is the potential difference across the 30 ohm resistor? That's easy. If you have 10 ohms giving you 6 volts, then 30 ohms will give you what? Cross multiply 18 volts, right? 18 volts. If he asked about the battery, about the EMF of the battery, it would have been 24 volts. Wire is moved down in direction perpendicular to the magnetic field. 3 changes are suggested. Which changes increase the electromotive force in the increase? I didn't ask about if the direction would change or not. I need to increase the EMF induced in the wire. The speed of the movement increased. Okay, this is correct. The magnetic field is decreased. No. The direction is reversed. Again, no. I don't care about if I change the direction. And if I actually decrease the magnetic field, then the EMF or the PD will decrease, right? A wire is moved across a magnetic field. The induced current interacts with the magnetic field to produce a force on the wire. In which direction is this force? In which direction is this force? So this force on the wire, okay, this force there to produce a force on the wire, and as you move this wire inside, this is the reaction force. He's asking about the reaction force on the wire. So the reaction force on this wire would be in the opposite direction to the motion of the wire. It would be in the opposite direction. The wire wants to create a force to oppose the motion. Remember, to oppose the motion. So this force is in the opposite direction of the motion of this wire. A 100% efficient step-down transformer has VP and IP, which row compares the secondary voltage and the secondary current. Step-down transformers, so what happens to the voltage? The voltage decreases. What about the current? As you decrease the current, as you decrease the voltage, the current increases, right? Step-down transformer. The scattering of alpha particles by a thin metal foil supports the nuclear model of an atom. Why are alpha particles used rather than neutrons? Why are alpha particles used rather? They always travel more slowly. No, they are heavier. It is correct, but this is not the answer why we use alpha particles. Okay, the answer why we use alpha particles is because they have a positive charge, and well, they have a positive charge, they might be repelled or not. They will be repelled by the nucleus, right? And that's how he discovered that there is a nucleus, because due to this repulsion, he found out that there was something positive in the center of this atom, right? An iron nuclide is represented by the symbol shown. Which statements about the nucleus of the iron nuclide are correct? It contains 56 neutrons. Does it contain 56 neutrons? No. Nucleon number is 30. No. It's the neutron number. The nucleon number is 56. Proton number is 26. Yes, it is 26. This is the correct answer. A sample of radioactive isotope has an initial rate of 128 counts per minute and a half-life of 4 days. Initial count rate. How long will it take for the emission to fall to 32 counts per minute? So 128 divide by 2, this is 64, and then divide by 2 again, this is 32. 2 half-lives, right? 2 half-lives, meaning that you have a total of 8 days. 2 half-lives, so you multiply 4 times 2, which is 8 days. Several scientists are working in the laboratory. They're experimenting with the sources, which each emit ionizing radiation. 3 of the rules are shown. Which safety rules are for the precaution against the effects of the ionizing radiation? Effects of the ionizing radiation. Keep at least 2 meters away from other people. Other people? What? That's not a safety precaution. This is wrong. Do not stay longer than 4 hours per day in the laboratory. Yes, decrease the time of exposure. Stay behind lead-lined screen. Yes. Protection. Protective barrier. Which data is needed to calculate the average orbital speed of a satellite around a planet? You need to find the average orbital speed, 2 pi r over t. The distance from the satellite to the center of the planet. The radius. Yes, we do need the radius, right? The radius of the planet itself. Do I care about the radius of the planet itself? If you have the distance from the satellite to the center of the planet. So if you have the distance to the center of the planet, you do not care about the radius of the planet. You actually do not care about the radius of the period of rotation of the planet itself. Do I care about the period of rotation? No, I do not care about the. Okay, I do not care about the period. The time for the satellite to orbit at once, yes, orbital period 2 pi r over t, capital T. This is the orbital period. So these are the things you actually care about. Approximately how long does it take for the moon to make one complete orbit of the Earth? It takes around 1 month. The energy generated in stable stars comes from the nuclear reactions. Which type of reaction occurs in the sun? Fusion, right? Helium nuclei breakup, helium nuclei join together. No, hydrogen nuclei join together to form helium nuclei. 2 quantities define the Hubble's constant, the speed at which the galaxy is moving away, the distance of the galaxy from the Earth. What is the relationship between V and D, and what is the current estimate for H naught? The relationship V is, yes, proportional to D. As you increase the distance, the velocity would increase. The further away the galaxy is, the higher the speed. What about the current estimate for h naught? It's not 3 times 10 to the power of 8, that's the speed of light. It is 2.2 times 10 to the negative 18 per second. Okay.